Mars is an unpleasant place. It's cold, full of deserts, and has very little oxygen or gravity. The average annual temperature on Mars is 64 F. At its hottest, Mars could hit 80 F, near the equator in the middle of the day. In the Martian winter, however, temperatures could fall to 199 F. That's why the first requirement for visiting the red planet would be a spacesuit. But we were curious, how long could someone survive a summer day on Mars without all this fancy equipment, say, wearing only jeans and t-shirt, and while holding his or her breath, which the average human can do for a little more than a minute? The answer is, unsurprisingly, not very long. The most serious immediate impact would be from the low atmospheric pressure, that is nearly a vacuum compared to Earth. Chris Webster from NASA's Jet Propulsion Laboratory, which manages the Curiosity rover roaming Mars, said in an email, within minutes the skin and organs would rupture, outgas, and produce a quick, painful death. If not killed by the low-pressure atmosphere, there are many other environmental factors that make Mars inhospitable to humans without protection. Any humans on Mars would have to contend with a lack of oxygen, only about 0.1% compared to Earth's 20% of very cold surface temperatures, the ubiquitous and irritating dust, the intense UV radiation, surface chemicals, and oxidants, Webster said. One of those philosophical questions we occasionally ponder: what is nothing? Can nothing be something? If not, then how can something come from nothing? If there's one scientific field on the forefront of such conceptual paradoxes, it's quantum theory. And in quantum theory, nothing actually is something, sort of. See, according to quantum mechanics, even an empty vacuum is not really empty. It's filled with strange virtual particles that blink in and out of existence in time spans too short to observe. Nothingness, on the quantum level, exists on a level of intuitive absurdity, a kind of existence that is paradoxical, but, in some conceptual sense, necessary. Science isn't usually comfortable dealing with phenomena that can't be observed. That's what makes this latest breakthrough, from physicists at University of Konstanz in Germany, so very profound and important. According to their research, recently published in the journal Nature, the nothingness that exists on the quantum level is not only something, but its fluctuations can be grasped, manipulated, and perhaps even observed. That's not supposed to be possible on the quantum level. One of the truly mind-bending axioms of quantum mechanics is the idea that you can't measure something on the quantum level without fundamentally altering it. In other words, as soon as you attempt to observe some quantum system, the very act of observing it destroys it. What the University of Konstanz researchers are claiming goes against this fundamental principle. They claim to have peered directly into the darkness and to have seen it for what it truly is. Or at least, they believe they have uncovered a method for actually observing things on the quantum level without destroying it, getting a handle on nothingness. How did they do this? Their method essentially involves firing a super short laser pulse lasting only a few femtoseconds, which, if you're counting, is measured on the level of millionths of a billionth of a second into a squeezed vacuum. As the light fires through this vacuum, subtle changes in the polarization of the light can be analyzed to reveal a map, of sorts, of the quantum nothingness. The squeezing of the vacuum is the real magic of this method. Perhaps the easiest way to think about it relates to what happens when you squeeze a balloon. The balloon expands and tightens in some areas, and feels depleted in others. This principle is charted on the graphic seen at the top of this article. As the vacuum is squeezed, quantum fluctuations peak in some parts of the vacuum, while other parts actually drop to below the background noise level. If the method proves to be sound, it's a game changer. As the new measurement technique neither has to absorb the photons to be measured, nor amplify them, it is possible to directly detect the electromagnetic background noise of the vacuum, and thus also the control deviations from this ground state, created by the researchers, explains a press release from the university. The study still has its limitations. At best, it merely represents our first foray into the something that mysteriously permeates the void. It's an encouraging first step, however, one that promises to peer deeper at the philosophical absurdities of existence than ever before. What is there to see when you squint into the heart of darkness? We may soon find out. We first heard about it via an email from SLU, a company that airs live views of space, and they're hosting a broadcast about 2017 BX which they've nicknamed Rerun starting at 5:30 p.m. on Tuesday. Asteroid 2017 BX, according to SLU and data from NASA JPL, is similar to asteroid 2017 AG-13, which flew by Earth on Monday, January 9th. But this new asteroid is much smaller, at roughly 13 to 46 feet 4 to 14 meters, a cross between the size of a car and a bus, and is moving at half the speed, approximately 16,600 miles 26,700 kilometers per hour. This is too small and too slow moving of the rogue space rock to pose any real harm to Earth if its path had targeted our planet, and if it had been a loose pile of rocks, as most asteroids are, and not a metallic asteroid, it would break apart and burn up thousands of feet in the air, according to an asteroid impact simulator called Impact Earth by Purdue University. However, the last-minute detection of 2017 BX is just another example of how blind we are to the millions of NEOs that could smack into our planet and release many atomic bombs worth of energy. NASA recently had the opportunity to fund a space telescope called NEOCAM that helped find 90% of NEOs of a size that's hard to detect yet could pose serious threats to human civilization. However, it balked for reasons that have yet to be made public, choosing to other missions and ones to asteroids, no less. Depending on where you live, pause for a moment tonight Tuesday, January 24th at 11:54 p.m. and imagine a rock the size of a truck flying overhead at 4.6 miles 7.4 kilometers per second. Then imagine 300,000 much larger rocks out there that are big enough and moving fast enough to wipe out a major city. Sleep tight.